Hello guys, so today we are solving this problem, check if pairs are divisible by k, daily Leetcode problem. So let's read the question. Given an array of integers r of given length n and integer k. So we want to divide the array into exactly n by 2. That means n must be even number, okay? Otherwise we cannot divide into the equal numbers, right? So we have to make the n by 2 pairs such that sum of the each pairs is divisible by k. So return true if you can find a way to do that, otherwise false. So basically, for example, this is one array, okay, and k is 5. So we have to make all the pairs out of this array, and it's given that the length of the array would be definitely even only. So that means n by 2 pairs must be there, right? Now we have to make that each pair should be if we sum those pairs, it should divisible by the k. So for example, here 1 and 9. So if we sum them, it would be 10. So 10 is divisible by 5. Similarly, 8 plus 2, 10. 7 plus 3, 10. It could be 10 plus 15. So that is 15. Or 10 plus 5, that is 15, which is also divisible by 5. So this is what we have to do. That if this is possible, then we have to return true. Otherwise, we have to return false. So what would be our approach? So let's discuss first few things before going to approach particularly for this question. Okay. So as you can observe one thing. Let's say we have two numbers 3 and 4. Okay. So if we sum them up, it would make 7, right? So if it's making 7, that means it is divisible by 7, right? So let's say our k is 7, for example. If our k is 7, and if we go to take the remainder of these numbers, if I do the remainder with the 7, okay, so 3 mod 7, this will make me 3, right? Similarly, 4 mod 7, this also will make the 4 only, okay? So you can observe one thing here, that if the sum of the two numbers is divisible by number k, then their remainders, if we get the remainders, the mod of all those two numbers separately, that also would be divisible by that number k. For example, this is one favorite example we can take here. For example, let's say we have only 3 and we have to find all the numbers, which would be, if we sum with the that number, it will make the divisible with 7. So let's say I am removing 4 particularly. So you can observe here, if I'm making the mod here with the 3, it is giving me 3. That means if I find all those numbers which are giving me 7 minus mod of this 3, which is basically 3 in this case. If I get the mod of whatever number, let's say a equal to 3, so 7 minus mod of 3, okay. So this would be basically 4, right? 7 minus 3 equal to 4. So if I find all those numbers who are making the mod with 7, whose value, if we make the modulus with this number 7, and they are producing 4, then all those numbers would be the valid numbers which will make a pair with A. For example, so you can see here, let's say I am taking these values 11, 18, 25. So what is the mod of 7 with 11? It would be 4. That means this also number a valid number. So if we combine A, if we add A, this 3 value with 11, basically it is making 14, which is divisible by 7. Similarly, come to 18. What is the mod with 7? It is making 4 only. So 7 minus mod of 3, this is 4 only. So this is also a valid number, right? Similarly, 25. So what this mod making? It is making 4, which is equal to 7 minus mod of 3. So all those numbers which are making modulus equal to 4, those would be the valid pairs, okay? But these are the only positive numbers which we have taken so far, right? But we have to look for the negative numbers as well. We just cannot write a solution only for the positive numbers. So let me take some scenarios of the negative numbers as well. So see here, I'm taking minus 11. So what would be the mod of it? If we do minus 11 mod 7, what would be the value? Right? So I am doing this. So it would give me what? It would give me minus 4, right? It is giving me minus 4, but this is not equal to 4, right? So for negative numbers, we cannot go in the same way, the way which we were going with the positive number. So we have to write a common method which will handle the negative as well as positive numbers efficiently, right? So you can observe one thing here. Let's say we are calculating the mod of any number, negative or positive. So what we can do, a percent k, whatever it is giving to us, and then we are adding plus k. Okay, so I'm adding plus k, and then this entire one I'm taking again the mod with this k. Okay, like this. Now you might have a question that how can I say that this would be a better method to handle. So see here, when we had the negative, right, negative 11, when we started, we tried to get the mod with the 7, it was giving us -4, right? So whatever value it is given doesn't matter if we add the plus k into it, right? So if we add the plus k into it, this will, if it was a positive number, so anyway we are just adding plus k, which is already the divisible by this k, because k and k are same, right? So this will not produce any problem. But in case of negative number, we just get the number, and if we do the plus k, it will make the equivalent positive number, right? So things would be handled smoothly if we use this way to get the modulus of any number. Okay, so that negative and positive would be taken care. So this was all about how to get the mod of a number. Okay, now we will go for the approach of our question. Now suppose this is our array. Okay, for example, so first of all what we will do is, let's say if I am getting the mod of 3. Okay, so mod of 3 with 7, it will produce me 3 only, right? So it will produce me 3. Now any number which has having the 7 minus 3 equal to 4, any number which is producing a mod equal to 4, that would be my pair, right? That can make a pair with this guy. Okay, so if I do modulus with this formula, let's write down it here. So if I do mod of 3, so what would be the mod of 3? Mod of 3 would become directly, it would be 3 only, right? Use this formula. Now come here, what would be the modulo of it? It would modulus with the 7, it will produce 4 only, right? Similarly, we will come here, what would be the mod of it? See here, it will make it like minus 11% 7, so this will give us -4 plus, what is the k, plus 7. Okay, and then percent k, so again it is percent 7. So what would be the value? It would be 7 minus 4, so 3% 7, so this would be producing us 3, right? So this value would be 3 here. Now come to 18, so it would be 18, what would be, it would produce the 4 as the modulus. Now we found. So now you guys can observe that a pair which is having modulus 3, then k minus 3 means 4. So is there some pair which can have the value 4? Yes, there is a 2 value. So either we can pick this guy or we can pick this guy, right? So we can have like we did the solution for the 2 of them, right? Now we are going to another one. This is 3, right? So hey, we are again coming here similar way, that this is 3. Is there somebody who is having 7 minus 3 equal to 4 pair? So yes, we have there, right? So we got the 2 pairs here. We can say that yes, we got the answer. So now we can mention it, that you can observe here like 3 and 4 and minus 11 and 18, right? Both of them are making, so pair could be something like this, 3 and 4 and minus 11 and 18. Okay, so far things would be very clear, because this is giving us, if we sum them up, this is making 7, so 7 divided by 7 is divisible, minus 11 plus 18, that is also 7, that is divisible, so things are fine. Now we will we observe one thing, right? So if we look for the modulus, so 3 and 3 was produced 2 times, and 4 and 4 was produced 2 times, right? So we can observe that if a mod is produced n time, okay, if a mod is produced, let's say frequency of a mod is n time, then we have to check whether the frequency of mod k minus mod also should be n time only. Okay, k minus mod also should come n time only. In that case we can say that yes, it is valid. So what we will do is we will make a hash map, calculate the mod of all the numbers, and then we will again go back and go through with this hash map, and we'll check whether this is equal to same frequency of k minus mod n. Let's take one example. So this would be our hash map, for example, right? It would be mod and frequency. So we created here 3. Okay, so 3 came first time. So what is the frequency? Its frequency would become 1. Now it is coming 4. So 4 is also coming first time. So what we will do is we just created mod, right? And then we will storing. So again this is 1. Then we are coming to 11. What is the mod? Mod is 3. Then we will go to hash map. Does 3 exist? Yes, 3 exists. That means we have to increase it frequency by 1. Okay, so 3 came 2 times. Now we are coming at 11. So we'll create the mod. Mod is 3. Okay, so yeah, this is 4 basically. Yeah, so when we are coming to 18, we will create the mod. So we'll check, hey, 4 is there. Yes, it's already there. So we have to increase the frequency by 1. Now we have got the frequency of whatever mod came. Now what we will do is we will again traverse through it. Okay, we will traverse through this array or this hash map. Using this array only we can go, like again we are traversing through it, creating the mod, and then we will check that, hey, how many times 3 came? It came 2 times, right? So we got it came 2 times. 3 came 2 times. Then we will at the same time will look for the 7 minus 3. So it is 4. So how many times 4 came? So 4 also came 2 times, right? So 2. So this also came 2 times. This also came 2 times. So this gives us an indication that yes, all the values came equally number of times, the mod and the k minus mod. So we can say that this is a favorite case, that yes, this is true. But there could be a other cases as well. Let me cover them as well. So suppose I am adding these 2 more values, 14 and 7. Okay, so we will get the mod of it. So what is the mod of it? Mod is become 0, right? Then we will coming again here. What is the mod of it? It is coming also 0, right? So when 0 came here first time, it became 0, and it came once time. Then again we are coming here at 7. This is also 0. We will go here. So hey, 0 is already there. Yes, it is there. Then we will increase its frequency by 1. We are done now, right? So what we did is first we did this thing, right? Then now we are going to check again. So we are traversing through these values again. So we will traverse through this array basically. So we will go to 3, right? We will create the mod again, so which is 3 only. We will check here. Hey, it is came, yeah, it's there, and it came 2 times. Then we will look for the 7 minus 3, right? Immediately after creating the 3, then we have to make the k minus mod of it. So this is 4, right? So hey, how many times 4 came? 4 came 2 times. So this pair is fine. Till here we are fine. But when we are coming to 0, right? So this time it is producing, when we are coming to 14, this time it is producing 0. So hey, how many times it came? It came 2 times. It came 2 times. But see here, we are not here. In case of 0, we don't have to do k minus mod, because it will give the k only. So in case of 0, what we have to do, whenever we are finding a mod equal to 0, after storing, we will traverse through, right? Whenever we are finding the mod equal to 0, basically we have to check that how many times this 0 mod occurred. Okay, so if it is even, this indicates that there could be like a pair possibilities there if this 0 appeared even number of time. Okay, so if it is even number of time, then we can say that yeah, everything is fine. But if even at a one place, if it is anyhow this frequency is odd, right, in that case we can say that this is false. For example, there was one more number 21, right? If 21 also was there, then 0 would have come 3 times. So then till here 3 and 4 are making fine, they can make the pair. But when it comes to 0, it is basically coming 3 times. That means we cannot make the even number of the equal number of pairs having the 0 mod. So if it was 14 and 7, we could have made another value, right? 40 and 7. But if we have 14, 7 and 21 as well, then we are not able to make, because it is odd number of times. So we have to return false in this case. Okay. So this is all what we have to do. Okay, this is pretty simple. First we will go through array. We will get the mod of them, and whatever mod comes, we will store the frequency into the hash map. Once we are done with the storage, then we will again come with this array. Again we will create the mod of every number and we'll get the frequency of it, and at the same time we'll also get the frequency of k minus mod in this. So if they are equal, then we will keep on going. If any place, if they are not equal, or if the mod is equal to 0 and its frequency is even, then we have to return false. Otherwise we will come out of loop and we have to return the true. So let me show you corresponding code of it. So see here, this is our method. I just created one HashMap. Okay, then see here, I'm traversing through this entire array, and see here I am creating the mod using just same formula, this formula. Okay, and then I'm creating the mod of them and I'm storing them into the HashMap with the frequency of it. Okay, get default. Get or default I0 plus 1. If it already existing, then it will return whatever value, otherwise it will return plus 1. Okay, so we are doing this way. Here we got all the mod frequencies of the numbers. Then see here, I am again traversing through this array. Okay, the same array, original array. Then I am creating again a mod of it. So first of all, I am checking that if this mod is 0, then see here I am looking for the frequency, that if it is odd number of time, I am immediately returning false. Otherwise, if it is not false, then we have to continue in the for loop. And see here, then I am taking the whatever mod we got, right, the frequency of that mod p, right, and here I am getting the frequency of k minus I mod, right. Then I am checking. So if at any place, if they are not equal, that means we cannot make the pairs. We are returning immediately false, right. Otherwise, if everything is fine, we will not return anywhere in the for loop. That means everything is fine. So finally we are returning the true. So let me execute my code. Yeah, it is working fine. Let me try to submit it. Yeah, so it is accepted. So thank you guys for watching this video, and if you guys have any concern, please make a comment over there. And we are using O of n time complexity. So we can solve this problem using sorting the array and then using 2 pointers as well. But that will take n log n. So we are supposed to do this in best time complexity, that is O of n. So thank you for watching this video.